Yeah, thank you for your invitation. And I think my talk is going to be much less poetic than the one before, because I'm going to speak about collaboration process during biodesign between designers and biologists in the context of the Biodesign Challenge. So I conducted a study a few years ago where I tried to analyze in different way how designers and scientists, mostly biologists, collaborate. And when I will talk about biodesign, I will mostly speak about designing with the very microscopic scale organism.
Marguerite, would you like just to try to reshare your screen a minute? We're seeing somehow we're seeing just half of your screen. I don't know whether it's, maybe if you put into play mode, that seems better. Yeah, that's better. Yeah, thank you.
You see it well? Yeah. Okay, so I'm Marguerite Benony. I'm a designer and I hold a PhD in ethnography and anthropology. During my PhD, I did an ethnographic field research in a biophysics laboratory in Paris, where I describe the work of biophysicists as the same way as the work of designers. And I try to make a little shift in the way researchers, scientists work in the lab. So, and back in 2018, I taught a biodesign course for participating to the Biodesign Challenge. The course happened between two institutions in Paris, which are the CRI, the Center for Research and Interdisciplinarity, with students mostly studying biology and biological systems, and the French renowned design school, which is the École Boulle. During the Biodesign Challenge course, I work with a group of 11 students, which are 5 master students level in biology from French University and 2 postdoctoral researchers in synthetic biology who supervise the project with me. Among all of those participants, none of them had worked across discipline before, so it was a really first start for everybody. Over the course of the collaboration, the biology and design students broke into 5 teams to give birth to about 4.5 collaborative projects that happened at the CRI. As part of the project, the students were introduced to very fundamental concepts in biology and exposed to hands-on laboratory work. But in all the projects, no explicit methods, no tool were imposed. And to see how the different students naturally collaborate together, we let them developing their own methods, and they were very free to arrange the collaboration in the way they suit them best. So for some of you who were present at the final in 2018, here is displaying on the screen the picture of the project Minima. This project has been designed following the study of the creation of a quick and easy DNA detector system by a PhD student at the CRI, while developing this project, 2 designers and 1 biology student from the Biodesign Challenge group joined to work with a researcher. And they made a very simple kit made out of ceramic, glass, and metal that would enable anyone to detect specific DNA sequences in the food at home. And so what they did is basically the design of a tool for making a well-known PCR protocol, but without any electric grid. Sorry, their focus was both on the design of the different objects that compose the kit, as well as imagining different scenarios to deploy it. And the interesting part of the work, beyond the object itself, is the collaboration process that happened between these PhD students working on this technology and this group of biology and designers that came up with this new protocol that they extracted from his research. So what I'm going to develop a little bit further now is how did this group collaborate, and how other groups of the Biodesign Challenge project, the CRI and École Boulle Biodesign Challenge project, work together. So to ensure that biodesign collaboration led to rich outcome, we need to better maybe understand the role performed by both biologists and designers during those collaboration. So after the projects were done, I interviewed all participants to tell the story of the project. I recorded and those interviews and transcribed them in order to analyze them. For their analysis, I assumed that each story that was students were telling me were developed chronologically and in order of importance at the rhythm of the project as it happens in real life. After a first analysis of all 11 interviews, I found out that each project follows the same pattern, and that could be divided into 4 phases, which are discovering, defining, developing, and delivering, which can be very typical in some standard design methods. But once I had this first pattern, I wanted to dig a little bit more, and I tried to find a way to visualize the dynamics of the role between designers and biologists at each of the 4 stages. So I designed a graphic system in order to see each stage of the project, whether an action was attributed to a designer or a biologist. And each action is relocated by a line reference in order to make all graph comparable. We observe here all the 5 projects, and we can see a very strong role dynamics between designers and biologists in their collaboration. In this analysis, I found that all the projects follow a very similar structure in which during which designers and biologists play very distinct roles that I have been able to identify. For instance, in the initial discovery phase, designers act as guests while biologists were acting as a guide to show new items to designer in the laboratory. In the defining phase, biologists became influencer and tried to bridge the gap between designers' idea and the reality of the biological life, which can be tough. In the developing phase, designers acted as apprentice and amateur, really, while biologists acted as supervisor and librarians. And during this phase, a very strong hierarchy could be seen between biologists who were really the mentors and teachers and designers who were really the students. And finally, in the delivering phase, all biologists were at first a bit evented from the design process. At the end, both disciplines really collaborated on equal terms for crafting the reasoning that supported the project. Sorry, I have a good gesture now. While the word collaboration implicitly evokes working as equal peer, designers mostly develop an instrumental relationship to biology, and this is what I could see from this analysis. And they really adopt biology as a material, and do not really include biologists in the design process. Biologists, on the other hand, really play the design game. They adapt it to designers' ideas. They try to make them viable. They take on the role of bridging, doing the bridge between designers and the biological practice, the reality of biological practice and knowledge needed to achieve the project. So by studying the tension that arose in the project, we found that collaborative biodesign projects still challenge key aspects of the project, questioning some very traditional assumptions in design, including questioning science authority, negotiating the complexity of biological material, or conciliating the scale of biology and design. But I think there is a huge gap to go over between really taking biology as in its materiality, as it's what is happening now, from taking biology as a discipline, and a discipline at its own tradition, its own practice and methods. And I think as designer, we should really try to dig more and to understand more what it consists in, to make really relevant biodesign project, at least at the microscopic scale. Well, this was my presentation. Thank you very much for listening. And I'll be all yours if you have any question.